All right, so this is our last section we're covering in this class. So this one's going to take those factoring methods that we just learned in the rest of chapter 6 and apply them to solving quadratic equations. So first thing I want to do is just recall linear equations, because it's really important to know the difference between the two because they have two different methods for solving them. So recall that a linear equation has the form ax plus b equals c. So it just has an x. There's no exponent on that x. It has an exponent of 1. So it does have an exponent, but it's always going to be 1. A quadratic equation is going to be of the form ax squared plus bx plus c equals 0. So it's going to be, looks like one of the trinomials that we have been factoring, ax squared plus bx plus c, except that it's an equation now, so it's going to be equal to 0. So this is called standard form. And this is something when we're solving these, we always want it in this form. We always have to have it equal to 0. And a couple things we have to specify is that a cannot equal 0. If it did, this whole term would be gone, and we wouldn't have an x squared, which means it would be linear, not quadratic. And then as usual, a, b, and c are real numbers. We're still not dealing with any of those i's. All right, so some examples just of what they could look like. Something like x squared plus 5x plus 6 equals 0. This one's in standard form, so that's the form we want it in, and then we'll be factoring to solve it. It might not be in standard form. It might be something like 2x squared minus 3x equals 6. So this one isn't in standard form, but we still have an x squared, which is what makes it quadratic. And then it's equal to 6, which is fine. We would just rearrange it to solve it. And it could be missing the x term or the constant. So we might have something like x squared equals 4. We still have an x squared, we just don't have an x. Or something like x squared plus 3x equals 0. Or let me change that one. Let's say we had x squared equals 3x. This is also quadratic because we have an x squared. We just don't have the constant, which is perfectly fine, still quadratic. And now, in order to solve these, we're going to use something called the zero factor property. Now, there are other methods, and if you go into Math 96, you'll see all the other methods that we can use to solve these equations. You might remember the quadratic formula. That's one of them. The zero factor property is something that lets us, if the equation is factorable, then we can use this property to solve. And it basically says if a and b are real numbers and a times b equals 0, then a equals 0 or b equals 0. Which makes sense, because if we have two things being multiplied, we have, let's say we had 5 times something equals 0. In order to multiply something, this number 5 to get 0, it has to be a 0 that goes there. Same thing if we had something times 7. The only way to get 0 here is 0. So if you have two things being multiplied and equals 0, either one or the other has to be equal to 0. So both of ours are going to have variables in them, so we're not going to know which one. So we're going to have two different answers for these, which is why we have an x squared. This x squared implies that we have a maximum of 2 solutions to our equations. When we had an x, we had a maximum of 1. Most of the time, we did have that case where you had an infinite number of solutions. With these ones, we're not going to run into that issue. So let's go ahead and just start looking at some. And they're going to start off pretty nice. We're told to solve, so solve means you're finding what x is equal to, or whatever the variable is. This first one is x plus 2 in parentheses times x minus 5 equals 0. So, a couple things we're looking for. In order to use this property, it must be equal to 0. And it must be factored. Like the name of the property implies, it's the 0 factor property, has to be done with factors. So if we look at this one here, we have it equal to 0, and the left side is factored. If we had something else on the end, let's say there was a plus 4 after the parentheses, that is not completely factored. The left side, you want to just have a quantity times another quantity, and that's it. So let's go ahead and erase that. There we go. Use our 0 factor property. So what we know is that one of these groups has to be equal to 0. So we're going to split this up. We know that either x plus 2 has to equal 0, or x minus 5 has to equal 0. So your two factors are going to get split up. And then all we have to do is solve each of these. They're just regular equations like we've seen a ton before. So I'll subtract the 2 on the left, and we get x equals negative 2. And then add the 5 on the right, and we get x equals 5. And so we have our two solutions for this one. If we wanted to go ahead and check this, what you want to do is you want to check each one of them separately. So I would check, let's say x equals negative 2 first. All we have to do is take this and plug it back in. So negative 2 plus 2 in parentheses times negative 2 minus 5, and we'll just go through this one, equals 0. Simplify inside the parentheses, so negative 2 plus 2 is 0. Negative 2 minus 5 is negative 7. And 0 times any number is still 0. And so you can do the same thing with x equals 5. I'll skip over that one, but I would definitely try doing the check for this one. Okay, so that's the first one. This was a nice setup. It was already factored and equal to 0. Let's try a couple more of those to kind of get the hang of it. Number 2, 3x minus 2 times x plus 6 equals 0. So again, make sure you have it factored and equal to 0. So we have our two factors here equal to 0. So we know either this 3x minus 2 equals 0, or x plus 6 equals 0. And now let's go ahead and solve both of these. So we'll add the 2, and we get 3x equals 2. Divide both sides by 3, and we get x equals 2/3. Again, just keep these in fraction form. Don't change these to decimals. And you can leave them as improper fractions or mixed numbers, but this one isn't either of those anyway, so we'll just leave it just like this. And then our other one, if we subtract 6, we get x equals negative 6. All right, so now let's go ahead and try one more of these. This one looks a little different. We're given z times 2z plus 5 equals 0. Now looking at this one, we don't have two groups of parentheses like we did up here, but we still have it factored. Think of this like a greatest common factor we took out. We have z times this group. We can put that z in parentheses if we wanted. It still means multiplication. And so now when we split this one up, we know either this first factor has to equal 0, so either z equals 0 or 2z plus 5 equals 0. Now with z equals 0, there's no solving to do, so this is actually one of our solutions. And if we plugged it in up here, this would be 0 times this whole group, which gives us 0. And our other one, let's subtract 5. So we get 2z equals -5. Divide both sides by 2. And we get z equals, again, I'll leave it as -5 over 2. All right, so those were all nice. Those were all factored for us and equal to 0. So let me just add in the note that it must be in standard form. So if it's not factored, we want it in standard form, meaning ax squared plus bx plus c. Just means that your exponents are descending and it's kind of all multiplied out and equal to 0. All right, so let's try another one. This next one, we're given m squared minus 3m minus 10 equals 0. So a couple things to check here is first, is it equal to 0? It is, and it's in standard form. It's m squared, then the m, then the constant. So now, this is one step before what we did over here. So these ones were already factored for us. So first thing we have to do here is factor. So we have 3 terms, big X, multiply to -10, add up to -3. If you go through all of your factors of 10, we're going to use 5 and 2 with a -5. And this is one where we can go straight to the parentheses. So we're going to have m minus 5 and m plus 2. All right, we're factored, but we're not done. We still need to find our two solutions, so we can split this up. So either m minus 5 equals 0 or m plus 2 equals 0. Solve each of these. So we get m equals 5. And subtract the 2. We get m equals -2. Okay. Let's try another one that's pretty similar to that in terms of factoring anyway. This next one is r squared plus 2r equals 8. First thing you should notice here is that it's not equal to 0. So first thing we want to do is set equal to 0. And that just means take any terms that you have on the right, move them over to the left. So I'll subtract 8. It's not like terms with any of these, so I'm just going to kind of tack it on the end. So r squared plus 2r minus 8 equals 0. Now that it's equal to 0 and in standard form, we want to go ahead and factor. So we have 3 terms, big X, multiplying to -8, adding to 2, And so our two numbers here are going to be 4 and 2, and we have to have a -2. So we have r plus 4 and r minus 2 equals 0. And then if I go ahead and split this up, we get r plus 4 equals 0 and r minus 2 equals 0. So solving each of these, we get r equals -4. And adding 2, we get r equals 2. Now, one thing that I've seen happen a couple times is people see that these numbers here are the opposite of what your solutions are. This happens when you have these trinomials that factor nicely like this. If we were looking at something, a trinomial where you had to split the middle term, these are not always going to match up with what your solutions are. So make sure you're actually going through and factoring and setting it equal to 0. It's really important that you go through and do those steps because it's not always going to work out like this. Okay, let's go ahead and try another one. Factoring is a little bit harder on this next one. (4x² minus 2x equals 42). Okay. So first things first, is it equal to 0? No, it's equal to 42, so let's move that one over. Subtract 42. So we have 4x² minus 2x minus 42 equals 0. And now for factoring this, we can take out a greatest common factor first. Let's factor out a 2. So we have 2x² minus x minus 21 equals 0. I'm going to just focus on this inside part and I'll bring the 2 back in a second. But we have 3 terms here. We want to multiply the 2 and the 21. So we're going to multiply to -42, add up to -1. So if we go through all of our factors, we're going to get 6 and -7. Go a little bit faster through that now. If you want to pause and kind of list them out, you can. And let's split our middle term. So we have 2x². I'll put the -1 first, so minus 7x plus 6x minus 21 equals 0. Let's go ahead and group our first 2 terms and the last 2 terms and factor out. So we can take an x out of this first group. We're left with 2x minus 7. We can take a 3 out of the second group. So we're left with 2x minus 7. And now finally, we'll bring this 2 back in, factor out this 2x minus 7, and we're left with x plus 3. And this is still all equal to 0. Make sure you're bringing that down every single time. This is about as messy as the factoring is going to get just because you had that greatest common factor in the front. It doesn't always happen. So now let's go ahead and split this up. So now if you notice we have 3 different factors. One of these is not going to give us a solution. And if you take a look at this first equation, you'll see why. So splitting this up, we're going to have 2 equals 0, 2x minus 7 equals 0, and x plus 3 equals 0. So 2 equals 0 is just a false statement. It doesn't tell us anything. That's because we don't have an x there. So anytime you have an expression, a factor like this that doesn't have an x, It's not going to give you a solution. We can kind of just ignore it. But these other two do give us a solution. Let's go ahead and add 7. So we get 2x equals 7, divide by 2, and we get x equals 7 over 2. And then subtract 3 on the other one, and we get x equals -3. So one thing to keep in mind when you're going back and checking your solutions, make sure you check them in the original problem. So if we were to plug this -3 back in, you'd have to do it up here to this very first equation, not to any of the ones that you did anything to it, because you might have moved terms around incorrectly or factored wrong. That one happens all the time just because factoring has a lot of steps. Always check it in the original equation. Okay, let's try another one. Let's do 49x squared minus 9 equals 0. All right, so this one, it's equal to 0, but it is not factored. So if we take a look at this, we have two terms. Remember, we either have perfect squares or perfect cubes. We have perfect squares, so I'm going to set up our two parentheses. 49x squared is 7x times 7x. 9 is 3 times 3. Put a plus and minus. Now it's factored and equal to 0, so let's split this up. 7x plus 3 equals 0. And 7x minus 3 equals 0. And now let's solve for x on both of these. We get 7x equals -3. Divide by 7, and we get x equals -3/7. And on the other one, let's add 3. We get 7x equals 3. Divide both sides by 7, and we get x equals +3/7. So this is one thing you should see when you're factoring or solving equations with perfect square binomials, is you should get two answers that are the same, just with a different sign. That's just what happens when we have these perfect square binomials because of the way they factor. Okay, let's try just a few more here. M squared equals 3m. So first things first, is it equal to 0? No, so we want to go ahead and set it equal to 0. We only have two terms here. Always try to keep this m squared positive. It's going to make factoring easier. So I'm going to subtract 3m from both sides. Now remember, you're subtracting the entire term. Because it's being subtracted, these are not like terms, they can't be combined. So we have m squared minus 3m equals 0. If you're wondering why we can't divide by m, I've heard that one before. It's because we don't know what m is. If m is 0, we're not allowed to divide by 0. So you have to just subtract it over. And doing it this way, we're going to get two different answers. If you did it the other way, you would only get one. So always make sure you're getting all of the terms over to the left. We started with two terms, so we should have two terms on the left. All right, now let's go ahead and factor. GCF first, we can factor out an m. So we're left with m minus 3 equals 0. We are completely factored, so we can split this up. Remember, this m is its own factor. If you want to put it in parentheses, you can. So we get m equals 0, which is one of our solutions, and m minus 3 equals 0, which gives us, after we add this 3, m equals 3. So we have two solutions. We have 0 and 3. Okay, let's go ahead and try two more. P parentheses 4p plus 7 equals 2. Okay, so this one looks a little more confusing because the left side is factored. We have two things being multiplied together. However, the right side is not 0. So even though it is factored, it isn't equal to 0. So we have to be careful with these. We need to make it equal to 0. If we just subtract it over the 2, there's nothing to combine it with. And then it's partially factored, but not completely. So what we want to do first here actually is distribute. Looks like we're kind of undoing the factoring, but this factoring doesn't work for us because of that extra 2. So if we distribute, we get 4p squared plus 7p equals 2. Now let's subtract over the 2. So we get 4p squared plus 7p minus 2 equals 0. And now it's just like one of the others that we looked at. We're factoring. We have 3 terms, big X. And let me move this over so I have room for our last problem. We're going to be multiplying to a negative 8, adding up to 7. So our two numbers here, if we went through all the factors, we need 8 and a negative 1. So let's split the middle term. We got 4p squared. I'll put the negative 1 first, so negative p plus 8p minus 2 equals 0. And now let's group our first two terms and our last two terms. Factor out a p from that first group, so we're left with 4p minus p divided by p is 1. Be really careful with that one. Don't lose that 1. We can take out a 2 from this group, so plus 2 times 8 divided by 2 is 4. P minus 2 divided by 2 is 1 equals 0. Let's factor out this 4p minus 1, and we're left with p plus 2. Still equal to 0. Make sure you're not dropping that off. It's really easy to drop that off and then forget that you're trying to solve. I've seen a lot of the times where people will go through and factor and then just kind of stop. Make sure you don't lose that equal sign. So now that we have this, we can go ahead and split this up. So either 4p minus 1 equals 0 or p plus 2 equals 0. Solving each one of these, we get 4p equals 1. Divide by 4, and we get p equals 1/4. Subtract 2, and we have p equals negative 2. So, big thing from this one, make sure it's equal to 0 and factored. If it's factored but not equal to 0, you're going to have to redistribute and then move that number or term over to the other side. So that's a big one here. Let's go ahead and try one more that's kind of similar to that. Number 10, 2 parentheses y squared minus 1 equals negative 3y. So this is another one that the left side is factored, almost. We could factor that y squared minus 1 again, but we're not going to because it's not equal to 0. So first thing I'm going to do here is distribute, so we can put it into standard form. So we have 2y squared minus 2 equals negative 3y. Let's add this 3y to the left to get it equal to 0. And you want to make sure it's in standard form for factoring. So I'm going to leave the 2y squared in front. I'm going to put the 3y next, so plus 3y, and then minus 2. If you want to write it as minus 2 plus 3y, you're going to have to rearrange so that you can factor it. Now it's equal to 0 and it's in standard form, so let's go ahead and factor. Big X, because we have 3 terms, multiply to negative 4, add up to 3. So we're going to need a 1 and a 4. The 1 has to be negative. So let's go ahead and split our middle term. Keep the 2y squared. I'll put the negative 1 first, so negative y plus 4y minus 2 equals 0. Group the first 2, group the last 2. And then our first group, we can take out a y, and we're left with a 2 and a y minus y divided by y is 1. And then again, 4y minus 2, we can take out a 2 plus 2. 4 divided by 2 is 2 and a y minus 2 divided by 2 is 1 equals 0. Let's factor out this 2y minus 1. And we're left with y plus 2. And now finally it's factored equal to 0. Let's split this up. 2y minus 1 equals 0, and y plus 2 equals 0. And so if we go ahead and add the 1, we get 2y equals 1. Divide both sides by 2. Oops, just 2. And we get y equals 1/2. And then finally subtract the 2, and we get y equals negative 2. All right, so that's it for this class. You guys got lucky. You're going to be able to skip over 6.8, which was some word problems. So that's good. So final exam is going to be on Thursday and Friday. It's going to work just like every other exam, except you guys are going to be given a little bit longer on the exam. You'll be given 2 hours instead of an hour and a half. Most of you guys probably won't even use that much time. But do make sure that you get it done on those days. I'm only going to be giving extensions for the things on my syllabus, so documented medical emergencies, or a university approved function, which there shouldn't be any right now, but if there are, no worries. And then if my math app has any outages, and I can see all those outages online. So if there's a planned one coming up, I'll let you guys know. And then all of the homework assignments are also due Friday at midnight. So if you want to get any extra points on your grade, make sure you work on some of those, but you do get 5 dropped homework assignments and 2 dropped quizzes. So I'll drop both of those on Saturday. All right, so we've finished all of our notes. Now all you have to do is go through and study up for the final exam.